right now. And we have also Mikhail is doing the streaming online right now, so there may be some people watch and the streaming. And if you want to get some pizza or drink during the time, just feel free to do so. And also later after this event, we will collect all the samples and the slides that we shared today on the Meetup page. And so yesterday, I also sent out a message to all the attendees so that you will also get the same update when we upload something on the internet. So I will start to do the sessions for the intermediate part for today's AI night. So the part that I will share today actually is 2 Jupyter notebooks. So maybe some of you already have the experience using Jupyter notebooks. Yes. And maybe some of you already use the Azure notebooks, perhaps. Yeah, someone's like, no, not yet. And someone's like, yes, I already tried. So actually later I will demo the service on the Azure notebook. So actually Azure notebook is still a preview service that you could use as a free service online. And currently it's served on the VM which come with the CPU machine. So actually you could do whatever that you want on that machine. And if you want to do some GPU training, later on I will show you how you could enable that environment with your own services. Okay. So before I jump into the notebook, the first thing is, later, when we open the portal for using the Azure Notebook, you'll find out actually for each of the users, you could create a list of the projects. And for this project, if your friends or your colleagues are willing to share as a public one, then you could click a clone button. So it's kind of the copy paste to your own space. So that, for example, the sample that I shared later, I will change it to the public one. So next time when you want to try it at home, you could just clone to your space and run it on your Azure notebook. So either you clone from someone else or you create one from your, with the Python 366 or with the Python 2.7. So let's say after you get the project setups, and then later you just make sure the Python and the packages follow the things that you want. And then next thing is you are just ready to go. So now I go to my Azure Notebooks portal here. So actually if you just Google this notebooksazure.com, you will go to here, and then you will see Microsoft Azure Notebooks preview. That means if you just come to this website, you could start notebooks, Jupyter notebooks as you want, just if you have the Chrome or you have the browser with you. So what's the best thing for this is if you just want to try it out to different projects, you don't have to install a lot of things on your computer. You just have it on the VM, and you could request as you need.
If I already have an ID,
yes.
How would I find that? Would I log in here? Or?
Okay, so for example, the question is if I already have the ID, then when I come to this page, what will happen next? So if you don't have the ID, then you see here is my name. If you don't have the ID, you will see the button called login. And if you already log in, like us, we already have it. And then you could go to my projects, here. So my project, you could have a list of the projects here. And then you could create a new one, and then create any projects as you want to make it public or a private one. So it's really you just create a project on your space, and you could also available to upload from a GitHub repository if it's open one, public one. And okay. So here you actually see the status. I have a different kind of the project here, and I have one which shows the green color and says running. So that means I have one project is running at the moment. That means actually when I want to run this notebook, that actually I could select if I want to run on a free machine on Azure, or if you already have your premium cloud on your office, you could try to connect to that one. Or if you have other cluster, you could also switch to the environment that you want to work on. So let's say if you just want to start a free experience on using Azure Notebook, you could just select run on free computer on Azure. So after you click the run one, you will see like the running on the free computer here. And then how you could check if it's on or it's down. So let's say if the computer is on, then you will see the shut down button. And the other way is if you didn't see like there's no button for shutdown, that means you are failing to turn it on. So it's kind of like they don't have a really like a green or the red button to show if it's this computer on or not. It shows with the feedback that you could see like the shutdown button here. So, so for now, you have the basic understanding about, okay, this is our work environment, and then you could easily to click clone button here. So when I share the link to you on the middle page, then you could click the clone one, and then you could get all the copy the same to your own space. So you could just play around it, and maybe you just change the subscription, change the resource group, and change the other things that is with your own resource. And also, like after this event, I will just delete all my resource just in case. Yeah. So let's see, in this project, what I want to show here, you could see actually there are 2 notebooks here. The one is with the cloud one, and another one I could show it here is with the start, page 2. I have the start Jupyter notebook here. So actually what I'm doing here, I would show a notebook with the MNIST data set. So how many of you already tried deep learning frameworks like TensorFlow, PyTorch, Keras? Yeah, cool. So actually, like some of you might know, like in the really beginning, TensorFlow take all the markets for most of time, and then later on, people would start to think about how to work these different frameworks together. Because, for example, if I start to learn deep learning with PyTorch, should I also spend another time to learn TensorFlow or the other frameworks? So actually now with one framework called ONNX, that means no matter which frameworks you're using, you use Keras, you use TensorFlow, you use PyTorch, you could export this model as the share format. So you could imagine like, let's say the share format for all the REST API will be, let's say, like a JSON format. So you could imagine in like machine learning world, if you want to export all the different kind of format to the same one so that we could communicate with each other, no matter you are in Windows, Linux, embedding system, and etc. So in this one, I will show the examples that in this machine, I installed some of the packages. The one is Azure ML, Notebooks, and AutoML. So for the notebooks and AutoML here, that you could use this framework to help you to do the parameter tuning and also help you to select some of the machine learning algorithms. And with the framework I installed here, Torch is also mean like the PyTorch, and Pillow would be the one if I want to show some script. And Torch Vision is something relative to the PyTorch one. So actually, when you start a VM, you could actually install your packages from Notebook, but you could also install your package in another way. Anyone had the experience about it? Yeah? No? Okay. So actually, let's go back to the project here. So actually, when you start in the really beginning, actually you could do a project setup here. you have all the namings, and there's one important thing is environment. So let's say if I am like super lazy one and I already know all the frameworks that I need before I really start the notebooks. So actually I will just import the requirement.txt. So this file will have a list of the frameworks that I need. So I actually just click this one and tell Azure Notebook, hey, I want this environment with Python 3.6 with this list of the frameworks. Then when you turn on the machine here, then you actually get it automatically. So either way, you know all the frameworks you need and turn it on like in the really beginning, or you could do it like on the fly, like when you start a notebook. So what's the pros and cons here? So for each of the virtual machine we opened in the notebook, if you have it like for a long time you didn't use it, or if you turn off the machine, next time will be turned on a different machine. So that means if you have to do it in the notebook, then it will be slower every time because you have to install it every time. And if you already know the frameworks that you're using, and then you already know in the list. So every time you open the machine, no matter which one you open, and then you always get all the things already before you open the notebook. So that's two ways that you could set up in your environment. So the next thing is import different frameworks that I want to use, and also import the data set here. So the data set here, we use the MNIST one, so which is like a really popular one. People would do the image recognition for just identify the numbers, which numbers it is in this picture. So actually, when people import the data, the most important thing for me is actually I would like to print it out the data before I do everything started. So no matter the data that I got is image, or the data I got is a row table with the data set, I would like to see it first before I really start to do the data cleaning or to do the data preprocessing and etc. Okay, so I would say it's like always you could try to print it out and then to see what kind of data you are facing right now. And the one function I like the most is because when we use the Azure AutoML framework, that could help us a bit to choose different kind of the framework that we're using right now. So some of the attendees come to me, it's like, hey, I just start to learn machine learning. I actually don't know how to structure different neural networks layers. How can I start? So in this notebook, I put 3 different kind of the layers. Actually, you could just try at home, and then you could change the parameters. You could add 1 layers as you want, or you could delete 1 as you want. And so later on, you have the feeling about what's the differences for the algorithms and the different structure. Then you have the confidence to change the layers or custom layers by yourself. Because I would say in the really beginning, people have less understanding from the mathematics background. So actually, people have more feelings when you see the data input and output rather than mathematics itself. So let's say I provide you a magic algorithms. I tell you there are tons of the formula inside. Were you willing to study that and then tell me what's the output? Or actually you just run the program and tell me the output what it is. So actually the neural networks is kind of like a black box and combine at least 5, 6, 7, 8 different formulas in there. So you have the feeling first, and then next one, you have the motivation to know more about what each the formula present about. So that's how I will suggest for people who just start to do the machine learning, and then you don't have the much feeling about mathematics, you don't have the much feeling about neural networks, how they calculate and so on. So you could start from the first one, and then you take like the baby step, and then you change a bit, you're confident to do the next one. So in this case, here I list the 3 different algorithms, the linear one, the network, and the convolution neural networks. So for these three, if you want to know what's the difference of these three, I would say it's the complexity of the algorithms or the formula itself within this model. And if you want to know more about the mathematics background, we could discuss after this one. So here, I said like, hey, I come with like 3 different algorithms here. And each of them, the things I want to make sure is the data input is the same dimension as the data outputs as I want. So for example, no matter which dimension, which kind of the framework that I choose, when I do the data import should be the same size as that I just showed you previously here. So what will be the output? The output should be within like 1 row dimension to show me this will be the number between 0 to 9. Right? So you have the basic understanding. When you see different kinds of the neural networks, you always ask yourself, the first thing, what's the input dimension and what's the output dimension? Because that will be the first frustrating things happens to you. For example, like this image you see like quite simple, it's just black and white. But when you have cars pictures, clothes picture, actually you have 3 colors on it. So actually the data dimension will so different than this one. So when you start to run, you want to replace algorithms, you want to replace the data set, this is the first checkpoint I will recommend you to start with. And then the next thing is then you have the confidence to change the layers. And then let's see, if we now start with compare 3 different algorithms with some default parameters that we want to run here. Let's say, hey, we just want to run 5 epochs here. We just want to know what's the idea behind it. And then here, we use the device here. Device could out if this computer with GPU or CPU. So as I mentioned, on the Azure Notebook, we only have CPU, right? So in this case, even I run the device CUDA here, it would tells me, actually, sorry, I only have CPU powered here. So that when I start to run it, so you will see select the model is from a linear one, neural network, or a convolution neural networks. Then you will got the cost function. That's how we evaluate if this correct or not. And we have the optimizers. This one is help you to know which function that you want to learn. And so after that, you load the data and you run it. And here, I have some output for the training one. So for example, we run 5 epochs here. That means each time we run, and then we have several outputs tell us what's the loss right now. So the goal that we train the deep learning models is we want to decrease the loss. So any of you want to answer why we want to decrease the loss here?
Because we want to predict as well as possible.
Yes. Yes. So actually, when we try to approach machine learning or deep learning, we actually have something that we could compare with. So when we want to predict if this number is 0, 1, 2, 3, 4, 5, actually we already have the correct answer to that. So when we calculate the loss here, that means the differences or the distance between the correct answer and the wrong answer. And the loss here, we could replace it with a different kind of the mathematic things. For example, you could say I just A minus B, or I could use A minus B with absolute value, or I want to get it with A minus B with absolute value square, or 3 times, or etc. So this was just one of the formula to show how correct that your model behave. So our goal is, once you could see that really beginning our loss is like from 0.3 and then decrease, decrease, decrease. And then after several different epochs, you will see actually the errors and the loss is decreasing by time. So actually, if we train more epochs here, that you actually found the model itself is behavior better and better by time. So also that means now we only have the CPU one. So maybe you could imagine about what if we could have the GPU one, then our model could have more powerful behavior on this. Okay. So after that, you actually will see the different predictions on it, and then you will get the output from it. Then we want to predict the result of it. So let's say, let's see if the predict digit match the actual digit. So in this case, when we want to evaluate our model, we try to put some input with the test data. That means the model haven't seen this data yet. So for example, when we go to school, we study some chapters on the textbooks. Then the teacher gives you a test, an exam, show you some examples that you haven't studied on the textbooks. So that's how teachers test us. Have we learned this chapter yet? So that's also how we test the model. Have you learned this data yet? So we put some unseen data points to our model, and then we want to compare how our model behaves in this case. So in this notebook, you will see, actually, we got some test error with some average loss here, 0.000700. So that means, so when we evaluate if we want to use this model in production or not, actually, we not only see the numbers, but we actually bring these numbers to our stakeholder, to our product owner, because we will ask them, what does this prediction means to you? So for example, if I just want to predict tomorrow which type of the pizza they want to order, I want to choose from 0 to 9 different flavors of pizza. So what could be wrong? Just wrong pizza, right? But if I predict wrong as kind of like in hotel, someone's got a cancer or different disease, is predict wrong. So that means this average loss has to be super small, so that when we provide our service, our customer will happy. So actually, when you see the number here, next time you could ask yourself, is that good enough? Or is like too good in my case? Yeah, so I would say usually when I run the model, the first thing is after I run it, I would just check with the project owner or some business partner that we work together just to make sure we didn't go too over to it. So if our business owner said that, oh, this case is extremely important, and the next we are thinking about how to fine-tune the model and make it more accurate, higher accurate or more high precision on it. And then there will be the important thing part that I mentioned here will be how you save the model here. And then we could save the model as the ONNX format, as I mentioned, or you could save as a model like the PTH. This one, we could use it later when we want to deploy our model on the Azure cloud. So the first notebook, we ended here. And so you could have a general idea about how we could actually run an experiment on Azure Notebook, and also with the CPU power. So actually, we could also run all the experiments here. But actually, later you will see actually when you want to training the data, it really runs like every 20 seconds per epoch, and then it's like wait forever. So that's why I want to go through this first. Then you could have the general idea about it. So when I now click around all the things again.
How many epochs will you get until the end? About 1,000 epochs or 10,000 or?
Okay, so the question is like how many epochs that I usually will try when I doing this one. For example, like this one, because we just want to try to double it. So I set it with like 5 or 4 epochs, as I remember. Like here, I set up with like 4. So it's a really small one. But in like real case, actually, I set up a lot of epochs, but also with the threshold for the lost. So you could actually say that I want to run 1,000th epoch. That means you run this whole experiment 1,000 of time. But when you see here, you'll find actually the loss is getting like less, right? And here you could actually decide if you want to do the early stop. So in the algorithms that you use, you could check if there's a parameter called early stop, or it's like save the best accuracy and so on. So there are different parameters actually you could set up. So let's say if I want to stop earlier, if it's the loss smaller than 0.000001, then I'm happy enough. I don't have to run 1,000 of epochs, right? So you could set up as either you run 1,000 of epochs, you run it like whole week, whole month, wait to the end. Or you're already happy about the loss itself. It's already small enough that you could use in your business. So you could have two different ways to make the model stop. Yeah. And any questions so far? I hope I didn't mention too many mathematical things here, so that you would like to clone this repository and try it at home. So actually you see here is something like metrics and mathematics here. So you could read it whenever you feel comfortable to do it. So actually when I start like a mathematical when I was in bachelor, but I failed several courses there. And when I really start to do like machine learning right now, I actually come back to see these formulas with real case. So now I have the real data for the user behavior. I have the real data for the numbers that you just saw. Then you put the real data into the mathematics formula. Then you know what does that means behind the scene. Instead of, hey, I just give you this book, and then you study all this by yourself. This will be more frustrated. Then you actually see your model is smart enough to identify different numbers here. It's like, what? My computer is already smarter than my dog or my cat, right? So it's kind of, you could start from a really small one, and then later on you could try with even more complexity models and etc. So any questions so far regarding the first one? Okay, now I will quickly switch to the second one. So the second one is, I know some of the attendees that you already use the product that Christian shown before, the Azure Machine Learning Studio. So actually the service I want to introduce here is, if you use Azure Machine Learning Studio before, you'll find out actually the machine that runs itself is a bit like the Jupyter Notebook. So it's run on a limited power source on it. So when you run the different kind of the experiment, you'll feel like a bit slower, it's stuck somewhere, and etc. That means now it's time you open your GPU machine. So actually, in this part, I want to show you how you could connect your notebook that I just showed you and then replace the background with the GPU power. And then you could use that to validate your model and deploy on the Azure cloud. So I know someone really like the fancy graph, so I would say something update on the machine learning Azure that you could have a look on. For example, before, if you have like a really beginning one, you start with the API, and then now you get more experience. Maybe you use Azure Machine Learning Studio, then you feel more confident to use PyTorch, Keras, ONNX is the one that I mentioned about. Exchange different formats so that they could communicate each other in different systems. And after this one, you could feel comfortable to use CPU, GPU, or FPGA. There's another chips from other companies, or even TPUs from Google, maybe. And then you could think of where you want to deploy your model. You want to deploy on the edge, cloud, or some other devices that you own. And here, so actually the things that I want to introduce here is machine learning workspace. So workspace itself contains a lot of resource. You could see like the experiment icon is actually similar to the icons that is from like a Jupyter Notebook. So you could think of, you could have the resource to do some different experiment, and you could have computer power, models, Docker image, and you could have something like a data stores and development. So it's like, it's really cool that everything is there, but it's also overwhelming, right? So we could also start from something that we already familiar with, like how to train a model. And then later on, we take one more step, like how to build image, how to deploy as a web service. And later on, I will need to open the GPU machine, which is the standard NC6, the first one, because I will just request one GPU. I don't really need much. And then you will see actually for each of different types of the machine, you could request different numbers of the GPU, and also different numbers for, I think this one is something customized or different features than the original this one. So actually later I will just show how to train your model with this one, the first standard NC6. Okay. And some nice pictures that you could deploy your service, and the end-to-end one. So this will be the things that I want to show now. So let's go to the Azure portal first. Refresh. Okay, so actually, how many of you already use Azure portal already? Yes, yes, yes. And so maybe not all of you using Azure, but you could also find like similar functions on Google, AWS, and etc. But you use the same like the mindset to make it the whole experiment and whole the functional happens. So when I want to create a resource here, you could just type machine learning. Machine learning. So here you could see actually machine learning serve workspace, machine learning studio workspace. So this one, machine learning studio, is the one that Christian just shown. And with this workspace, you could work with more powerful resource with it. And the service that I want to share later is machine learning service workspace. So when you click this one, then you will see some logo like this. And then you could say like create. So actually like when you create, so let's say September 5, and I also have another one, resource group, just the same, and I created the West Europe. So usually,
just choose the location. So if you have a free account set up, can you just do the same, or is it given to you?
You are asking about the location rate.
Yeah, yeah.
If you are the free account, so actually when you open like or create the resource for the Azure Machine Learning Workspace, it costs money. Yes. And why it costs money, I will show you here. Let's check all the resources I have here. This resource is actually I create earlier than today's event, but I only create one workspace, and it comes along with his friend. Container registry, key vault, application inside, storage account, and later on there are some service I want to serve online. So you could see you request workspace, and he comes with his good friend. So that means actually the service is not totally free, but I will show you when you want to use it. You could also feel free to use your local GPU cluster, and if you find out you want to use it with, because you want to know some insight from application inside, if you want to store some secret at Key Vault, so a lot of things already been here. So it just depends your use case. So actually, as I mentioned, if you create one workspace, it will come along with this group friend, so it will take some time. And then after you train your model and then you want to deploy one, you will get one service here, like PyTorch MNIST service. Then you will get more detailed about what kind of service that you're having now. Okay, so the second notebook that I want to share here, actually the frameworks that we use is almost the same, Azure Core or Azure Machine Learning and other things. So here, you actually will see when I create a workspace, I post, like, let's say, my subscription ID and my resource group and workspace here, all from the page that you could see here. Overview. I remember there's a key. No. Resource. No. Okay, maybe I would check later to see. Oh, actually, you could see from here. So the resource group is here, and the service name is here itself, and your subscription is also here. So actually, you could copy all the things from the overview page here. Then, actually, you are telling your notebook like which workspace I'm work with. So it's kind of connect the different details here. So when you run this script here, when you first time to do the connection, it will pop up some different windows because you have to log in your Azure account just to make sure you are the one using this resource. So for example, if you use this notebook and want to connect to my workspace, it would pop up on my computer to show if I want to do that or not. So I would definitely say no, because it's not my notebooks running. So let's say you replace all the things with your personal subscription, workspace, and etc. Then you will get a config that is kind of like connection string or authentication, other like details that you could connect to your resource. After that, you connect to the workspace, let's say what we saw on the portal. Then you could say, hey, I want a cluster. The VM is the powerful one that I just shown as standard and C6, the one with the GPU one. So actually, this is where I declare which model or which machine I want to work with here. And how many of them that I want to work with. So actually, the more powerful the machine that you open, the more money you have to pay, as you understand. But also depends on the different calculation time. So you could do different scales as you try. After that, we already declare, okay, now we got the GPU machine as we want. Now you want to run some different experiment here. So I put them like a different frameworks, model, and I also mentioned about what kind of the things that I want to run is with the GPU, yes. So that after I declare all the things that I want to run in this experiment, the next one is I really run on the machine. So that's one thing I want to note down here, because this notebook mentioned about if it runs correctly, you will see something here. But the fact is, this picture will not really show like here. You have to go to your workspace and to see the activities here, and then, wait a second, then you actually see in different kind of the experiment I run here. So I just randomly click one. Okay, then you will see like actually for different times that I run, for each of the experiment, it will show if this loss function has decreased or not. And in this case, it's like, this parameter sucks because it didn't behave well. And accuracy that you goes up and you goes down, it's like, why? So there might something happen to run within this experiment, but you could have an idea to know whenever you submit an experiment, you could always come here to your workspace and say, hi, I just submit an experiment. Can you just show me the graphic that regarding the loss function and accuracy function? And after that, when you finish all your training, when you see like the finish and done, you could click the output here. In output here, you will see actually different logs you could download to see if your machine's happy, the logs regarding the Azure Machine Learning Studio. And most important thing is you want to download the model, as I mentioned here, model.onnex or model.pth. So this will be the most important thing that you want to check, because like after, let's say, 30 minutes of waiting, you want this, most things comes, right? So you have to remember like where I can find the most important one, that is the trend model here. So let's go back to the notebook quickly. Yeah?
Notice, you provided the compute, the workspace programmatically, but there is no need to do this. If you miss this, you can press the run and then you have choose the compute, and this is connected to the workspace in the source group.
You mean if we don't declare which one we want?
You don't need to declare compute and resource group, workspace, and subscription ID. If you just remove this, if you want to run, then you have to select the compute from your Azure portal, and which one that you have created. So this is then the connection.
Yes, so your question was mentioned about our comment about this part would be if I remove this part, right? Yeah. So actually I only tried the parts if I create a notebook randomly, I want to connect to my resource. And the way that you mentioned, maybe we could also do it on the portal and then connect back to the local one. Because I also remember like in the workspace here. Yeah, sorry, here, here. Yeah. And then you could add different things here, like computer name and also the computer type and etc. So this will be connect to this different, let's say, machine learning compute, Kubernetes service, and etc. So this also another way that you could link back. So I provided one way that you could link from the notebook to this workspace. And this one is also a nice comment. You could also reach out from your workspace and reach out to different resources that you're already on. So good point for that. Okay, so when we go back to the subscription that we mentioned, and now we happily run the experiment. And here's the things that I did some changed from the original samples that we got. So actually, I go to the portal page that I just showed you. I download manually for the model file and upload to the workspace I work here. So you will see there are different models and model next here. That is, I did it manually because when I tried with the libraries, with this days, somehow it's not worked quite well how to sync this space together. So I use manually. So maybe later I could try if there's a better way to download a model and upload automatically, or there's a better way to do it. But I would say if you just clone this notebook, you have to do this part by hand. It's like download a model, upload to this one, and then let's go back, continue to this one. So I already upload everything here, then I register this model on my workspace. Then next one, I tell the Docker image about what kind of the frameworks that I'm using. I use PyTorch, I use NumPy, so please help me to build environment with this package. So later on, I build an image based on it, and then so I have the image create in this workspace, and with the tag name in it and the model itself. So actually you could see in the really beginning, we already run different kind of, from different resource like a GPU or a CPU one. After you run that, you actually want to deploy as a web service to others. So in the previous session, Christine showed you want to export the Azure Machine Learning Studio model as a web service. Also in here, we want to deploy our service as the machine learning service on the Azure Workspace. So after we deployed here, you actually will get an endpoint. So when you get the endpoint here, that means you could use either this way to code the service to prediction, not yet, here. If you want to know if your the model is working, then actually you could send a request to it, and you have the service URL, you have the image string here. So that means you want to test it out if your model works well. So let's say I just send it with different binary string here to just test it out if it's with a 0 or 9 numbers within here, and the score, different score of it, and the computer time I will get. So actually, when you want to try out the endpoint that you're deploying with, either you could try it with here, or you could check on here. This workspace, I already deployed something on the cloud. And then on this cloud, I could check different service or the endpoint I could co-work with. So either way, you could try on the Python script with the request framework, or you could also test it out with the Postman. Okay, so this is the part for the cloud deployment. So here, actually, the whole mindset is similar to the one that Christian just shown, but just we used a different way. The first session we mentioned about how to drag and drop so that you could just make an experiment by the module you already pre-built. And here we showed how you could build the frameworks and deployment with the Azure frameworks so that you could do it in more hardcore way, you could do more customized way, and also you could feel free to connect which computer power that you want to use. So in here, maybe you would have some questions about these two notebooks so far. Yes? No? Cool. So, okay, so let's say maybe you want to clone it on your local one, and then later on you will just try it out on your local machine. And if you have any difficulties to figure it out, like why the connection is so slow to my experiment is broken or somewhat, everything, like if you have everything struggling for the notebooks or the experiment, you could always feel right to us. Tell you how you could fix that, because sometimes you will just miss configuration for the environment 3.6 or 3.7 for your Python, or just the different frameworks you forgot to update. So yeah, I think that's all my sharings today. Yeah, not the services, and then I guess will be the next session.